Longitude Verification Method Statement. The Universal Numbers Group, or UN Group, Longitude Verification Method Statement, defines the calculation standard required for verifying the zodiacal longitude positions used in the UN Group. Full recurrence architecture, four-wheel recurrence architecture, 200-zone wheel, metonic cycle diagrams, and UN Group AGT. For verification purposes, the longitude positions must not be checked by casual astrology charts, simplified zodiac tables, average daily motion, equal degree assumptions, or approximate visual placement. They must be checked using the same high-precision astronomical basis that underlies Fred Espenak's NASA solar eclipse calculations, with the eclipse event anchored to the appropriate greatest eclipse time or defined eclipse reference time used by the UN Group. The purpose of this statement is to ensure that all degree position checks are performed from the same astronomical foundation. Required verification method. For UN Group longitude verification, the following calculation standard must be used. First, the eclipse date and time must be anchored to the solar eclipse data associated with Fred Espenak's NASA Eclipse-Wise eclipse catalog work, especially the greatest eclipse time when that is the reference point being tested. Second, the sun's position must be calculated from VSO-P 87, the planetary theory of Bretignon and Francoux. NASA's Espenak documentation states that the sun's coordinates in these eclipse predictions are calculated using the complete periodic terms of VSOP 87 version D, which gives positions referred to the mean equinox of the date. Third, the moon's position, where required for eclipse circumstances and eclipse geometry, must be calculated using ELP 2082, the lunar theory of Chaprant-Touzé and Chaprant. NASA's Espenak documentation states that ELP 2082 contains 37,862 periodic terms, including terms for lunar longitude, lunar latitude, and lunar distance. Fourth, the calculation must recognize the truncation standard used in Espenak's eclipse program. NASA's documentation states that periodic terms smaller than 0.0005 arcsecond in longitude and latitude and smaller than 1 meter in lunar distance were neglected, producing very small mean positional errors compared with the full ELP theory. Fifth, the calculation must use the moon's center of mass position rather than applying an center of figure correction. NASA's documentation states that Espenak chose to ignore the convention of applying a typical empirical correction to the moon's center of mass and performed the calculations using the moon's center of mass position. Sixth, the calculation must account for the value of delta t, meaning the difference between dynamical time and universal time. NASA's documentation states that delta t is part of the eclipse prediction framework and is based on the work of Morrison and Stevenson for the relevant historical modeling. Seventh, the calculation must account for the moon's secular acceleration value used in Espenak's eclipse calculations. NASA's documentation for the VSO-P 87/ELP 2082 prediction method states a revised lunar secular acceleration value of approximately -26 arcseconds per century squared. Eighth, for eclipse circumstances, the calculation must use Besselian elements derived from the sun and moon ephemerides. NASA's documentation states that Besselian elements computed for solar eclipses using VSO-P 87 and ELP 2082 were prepared for the 5 millennium canon of solar eclipses. Ninth, where zodiacal longitude is being verified, the output must be expressed as the sun's apparent ecliptic longitude at the chosen eclipse reference time, then converted into zodiac sign, degree, and minute according to the UN Group's stated format. The verification must compare the calculated longitude position against the UN Group charted longitude position or against the AstroSeek check value when AstroSeek is used as the practical verification tool. 10th, the verification must not substitute average degree motion or fixed 1.8 degree zone spacing for the actual solar longitude calculation. The UN Group zone system may average 1.8 degrees per zone, but longitude verification must be based on the calculated apparent solar position, not on average zone geometry. Formal verification standard. The UN Group longitude positions should be verified according to this standard. The solar longitude position for each eclipse must be calculated from the eclipse reference time using the same astronomical foundation as Espenak's NASA solar eclipse predictions. VSOP 87 version D for the sun, ELP 2082 for the Moon, where eclipse geometry is required, delta T modeling, lunar secular acceleration, Moon center of mass treatment, and Basilian eclipse circumstances. The resulting solar ecliptic longitude must then be converted into zodiacal degree position and compared to the UN group charted position. Practical AstroSeek verification statement. For practical checking, the UN group uses AstroSeek as a longitude position verification tool. In the UN group method, AstroSeek is used only when it is set to the proper eclipse date and reference time, and when the displayed solar zodiacal longitude corresponds to the astronomical position being checked. AstroSeek values must be treated as verification aids, while the underlying standard remains the Espinac-style astronomical calculation framework. A proper UN group longitude verification therefore requires the correct eclipse date, the correct eclipse reference time, usually greatest eclipse time, correct timescale handling solar ecliptic longitude calculation conversion into zodiac sign, degree, and minute comparison against the UN group charted position, and no substitution of average zone spacing for actual longitude. Final statement. The Universal Numbers Group Longitude Verification Method Statement requires that all UN group zodiacal degree position checks be performed from the same high-precision astronomical foundation used in Fred Espinac's NASA solar eclipse prediction work. The Sun's coordinates must be based on VSO P87 version D, the Moon's eclipse geometry on ELP 2082, with appropriate treatment of delta T, lunar secular acceleration, Moon center of mass, and Basilian eclipse elements. The final verification value must be the Sun's ecliptic longitude at the defined eclipse reference time, converted into zodiacal degree position, and compared to the UN group charted value. In plain language, UN group longitude positions must be verified by actual eclipse time solar longitude calculation, not by average motion, visual approximation, or equal zone spacing.